So in this video I'm going to demonstrate the mandatory practical how to find the heat content of ethanol. So you can see here I have a spirit burner with ethanol in it. I have a can with some water in. I've already measured the mass of the water that's been added. It's roughly 100 mils. So we did the mass of the empty can, added the 100 mils to it and then reweighed and just subtracted the empty can. I've recorded that here, so it's just over 100 mils, 101 point something, 301 grams of water that's going to be heated up in here. And the other piece of data that we need is the initial temperature of the water. So I'm using this digital probe, so that will allow you to keep an eye on the temperature here, and it's saying 20.1 degrees Celsius. So I'll pop that into the table. Initial temperature of water, 20.1 degrees Celsius. So the next measurement that I need to take is to see how much ethanol is in the spirit burner at the start. We're then going to allow the ethanol to burn and raise the temperature of the water, and we'll put the ethanol out and we'll weigh the spirit burner and the ethanol afterwards, and we can subtract the two masses from each other and find out how much actual ethanol has burned in there, calculate the moles, and we'll be able to work out how much heat has been provided per mole of ethanol. So I'm going to put this onto the balance. Actually, I might put the lid on as well because I want to weigh it with the lid at the end. And the mass has come out at 228.66, so I'll add that in here. 228.66 grams. It's just reading to 2 decimals now because perhaps that's a smaller, a larger weight of the mass. All right, so our next step is to double check the temperature and then to light the ethanol. So you can see that the ethanol is burning and it will be heating the water in the can. And as that water heats up, I'll give it a little stir so that we're getting an even measure of the heat throughout the water that's in the can. By having it in a soft drink can, it means I've only got a very small opening for water to evaporate through, so that means that the mass of the water will pretty much stay on around about 100 grams throughout, which is important when we come to do the calculation at the end. So let me just have a look and see if that's having any effect. Oh yes, that's having a huge effect. You can see we've reached 42 degrees Celsius. We don't want it to go too close to the boiling point, so I'll put it for a little bit longer and keep an eye on the temperature. It's a much more convenient way of measuring the temperature than using a thermometer, because I'd have to be sort of lifting the thermometer and peering at it to monitor the temperature. Okay, so we're around about 80 something degrees now, so that's probably a convenient time to stop heating because we're starting to have some evaporation of the water, and that's going to make our experiment inaccurate. So I'll pause there and pop the lid onto the burner, which stops it from so I'm going to weigh the burner with the remaining ethanol in it, pop it on, and the mass 226.62. And that will allow me to calculate the mass of ethanol that has burnt. So subtracting comes to 4.04 grams of ethanol that has, no, 2.04 grams of ethanol that has burnt. And the final temperature of the water can be taken from the thing. So you can use the data now to calculate the heat content of the ethanol in kilojoules per mole.